Hello everyone. Today we are going to look at a problem which is insert greatest common divisors in linked list, in which we are given a linked list and for each pair of adjacent nodes we need to calculate the GCD and insert it as a node between them. Adding a node between two elements is pretty easy. For each pair of nodes, previous and current, we create a node. Value of the node is calculated using GCD function. Node.next becomes current and previous.next becomes node. Since we do this for every pair, we use a loop where at the end of each loop, we update the previous to the current and take the current one step forward. When we start the loop, previous is the head node and current is its next node, and the loop ends when the current is nil. This also ensures that the loop will not execute when we only have one node. Now let's come to the GCD function and logic. We'll calculate the GCD using a Euclidean algorithm, which states that GCD of A and B is equal to GCD of B and A%B, where A%B is the remainder when we divide A by B. Let's try to prove this. Let's say that there is a divisor D which divides both A and B. So we can say that A equal to D times M for any integer M and B equal to D times N for any integer N. Now we can say that A equal to B times Q plus R for any quotient Q and remainder R. If we divide both sides by our assumed divisor D, we get A by D equal to B times Q by D plus R by D. Then substituting from 1 and 2, we get M equal to N times Q plus R by D. Since M comes from dividing A by D and N comes from dividing B by D. And we also know that D divides both A and B. Hence D should also divide the right hand side of this equation, which means that D should also completely divide R. We can also write the equation as A equal to B times Q plus A%B, where A%B is the remainder when we are dividing A by B. Since D should also completely divide R and R is also A%B. So to find D, we can also find the GCD of B and A%B. And then we can repeat the process till B becomes 0. So in each step, we calculate A modulo B and store it in B, which helps in swapping A with the current B and B with the current A modulo B. Then B becoming 0 would mean that we have completely divided A by B in the previous iteration. So in the current iteration, the divisor that we find would be stored in A and we return A. And when we run this, it submits. Thanks for watching.